Quantitative research involves facts that can be verified, counted. If you are using a quantitative method to produce something, you're using set procedures, laws, rules, toward a predefined goal, as in computer programming. Qualitative research involves the interpretation of facts. What is interpretation? It's a way of processing information. How does a machine process information? Traditionally, research in the humanities has required a qualitative approach. The study of literature, philosophy, history, art depends heavily on interpretation, understanding contexts. A literary theorist does not take measurements, usually. A physicist takes measurements. Researchers in the humanities do not generally try to make predictions. It is assumed that it would be impossible to come up with an algorithm for creating original works of art. An algorithm might create imitative works of art, formulaic works of art. Historians are somewhat exceptional among those working in the humanities in that what they study has already happened and things can be counted and measured. And it can be somewhat informative to understand how much or how many. Nevertheless, even with things about which there is certainty, past events, interpretation is still necessary to understand why and what it all means. But some of you are part of the Digital Humanities program. You seek to apply computational methods to the humanities. Why? Has anything changed with the humanities or with computational methods? To some extent, humanities researchers have always counted things. And now, keeping track of the counting is easier with computers. When I was a student, word frequency in Shakespeare was something that I might have to understand to correctly interpret a passage. I remember having to consult enormous books at the New York Public Library, poring through catalogs in tiny print of every word Shakespeare used and where, so I could determine how probable it might have been that he used the words straw and trick together in a sentence twice in the same play in seemingly unrelated passages. If it was very unlikely, then I could assume that Shakespeare's intention was to draw our attention and to compare the two passages and to come to some conclusion. Fortunately, scholars had already done all the laborious counting for me. I just had to look it up. But there weren't similar catalogs of less canonical authors. These days, of course, it's pretty easy to determine word frequency in any author with a search function. So computational methods, an algorithm that can search through text and match specific digits, make humanities scholarship easier. We can get to the interpretive aspects of our research without having to do so much grunt work. Or can computational methods do more than just grunt work? Isn't there a belief or hope that computational methods are coming closer to being able not just to count, but to interpret contexts? After all, computers don't do just simple arithmetic. I'm currently working on a problem trying to do a digital simulation to model the chemical reaction diffusion process that is behind the development of butterfly wing patterns. It's important for me, as a Vladimir Nabokov scholar, to help me understand better his theory of artistic creativity. He was also a lepidopterist that studied evolution. Nabokov made predictions about the probability of two similar types of pattern emerging in nature without the help of natural selection. I wonder if his brain was using quantitative methods or qualitative methods to make this prediction. We are wont to say that he was able to make good artistic guesses. But what would that mean? What's the difference between an artistic guess and figuring out a formula? Some are using computers to try to model neural processes, thought. Aren't we already in society using algorithms to make predictions about what people may want or may do in the near future? Are these methods qualitative or quantitative? Do we think that all research that currently requires qualitative methods might be done by computers someday? Can the human be replaced? Are neural networks beginning to imitate biological neural processes? In a quantitative versus qualitative methods course, you might expect to learn how and when to do one method as opposed to another. I'm a philosopher, so in this course, we aren't going to be doing that. We are going to ask the deeper question: what really is the difference between research subjects that require interpretation and those that don't? My field is biosemiotics. I study the differences between biological computation and machine computation. Living systems can interpret and machines can't, so far. Not the machines we have now, anyway. In this class, we will try to arrive at a more clear and precise definition of interpretation, a concrete definition. I want you to be able to visualize interpretation, not just have some abstract or vague general sense of what it means to interpret. Qualitative or quantitative? How long have we been making these distinctions? How long has it been said that different forms of knowledge require different approaches? Since Immanuel Kant and his distinction between the rational and the teleological judgment? Since Isaac Newton with the introduction of mathematics as the language of nature? Since Francis Bacon, who banished teleology from the study of nature? Is the distinction between systems that can be quantified, that can be reduced to a procedure, and those that can't, a false distinction? If you look at the syllabus, you'll see that a lot of our readings are going to be in biology. We are going to begin our investigation into these questions by looking at where they first crop up. In the earliest days of the life sciences, long before digital computers, the question arose: can biological processes be described and modeled similarly to the way that inanimate physical systems can? Are life processes reducible to chemistry and physics? In those days, the mathematical biology department was considered radical and unusual, and it would have been comparable to our digital humanities department today. At the conclusion of this course, you will have a much more than textbook definition of the differences between qualitative and quantitative research. Without being told when and how to do one versus the other, you will know what to do, what questions to ask, and why. One or some of you may go on to developing artificial computational processes that can make qualitative evaluations. Okay, so that's the end of my introductory remarks. The next thing that we did in that first class was take a look at the Next Rembrandt Project, which you can find by searching for the Next Rembrandt. So if you haven't already seen that video, it's just about 5 minutes long. Take a pause, take a look at that now, and then come back. The syllabus, which everyone has read by now, or should have read, talks about the Next Rembrandt Project. So what I bring up here is the question of why the people doing the Rembrandt Project chose Rembrandt's most typical paintings, the kind of paintings that he did the most, mainly portraiture for hire, commission jobs. And I remember one of our computer science students answered probably correctly because that was the most data. If they want an accurate representation of the kind of work he did, they need a lot of information. So accuracy was the goal, we imagine. I think that's probably correct. So the goal was not originality, it was correctness. And so I want to ponder for a moment on the uses of AI. Is it for correctness? And if so, what is correctness? Or is it originality? Here we are applying, the application is being made toward producing a work of art. So it seems like originality could have been the goal. And I gave a very famous painting, Old Woman Cutting Her Nails. It's sometimes called Old Woman Paring Her Nails, as an example of an imitation of Rembrandt that is quite good. It was believed to be an authentic Rembrandt for many years. The thing is, with Rembrandt's studio, it was a studio with a lot of students who did a lot of the work on all of the paintings that he painted, doing the background and the drapery and so forth. And he would come in and do the important key work on the face and the hands. So a lot of his paintings were actually kind of cooperative work. So it's hard to say what is Rembrandt and what is not. But so if we look at this painting, Old Woman Cutting Her Nails, what makes it like a Rembrandt? Why did it fool the scholars for so long? And this brings up the Alan Turing idea of whether or not a computer can imitate a human. Can a computer imitate an artist and fool people? Whoever painted this painting discovered the formula or was taught the formula that Rembrandt was using, or some of his formulas. And if we look at this, we can say it's dark. The room is mostly has a kind of cave-like darkness, which is typical of a lot of Rembrandt paintings. Again, typical is key here. There's a glow on the face and the hands; those are prominent. A lot of other things are sort of out of focus. It's a domestic scene. He did quite a few ordinary people. And so, certainly, an old woman cutting her nails is a very ordinary domestic scene. And that brings us to the assignment. Find examples of mimicry, parody, or imitation in nature, in art, or in music. But what I would like you to do is identify the formula, or try to identify some kind of a formula that was used to mimic the work. And so what we're going to be doing basically is trying to identify the kind of algorithm that defines that artist's style, or the essential defining characteristics of some creature in nature, if you're looking at, like, say, insect mimicry or something like that. Let's also look briefly at some examples of other computer-assisted mimicry of art. This is an example of software that has learned the algorithm for painting a Van Gogh-like painting. What are the features of Van Gogh here? Obviously, this is an imitation of Starry Night, and the defining characteristics of Starry Night are, glowing lights, a lot of blue, a lot of swirliness, a lot of thick paint. When an artist's style is easy to imitate, maybe it's not quite original if it can be reduced to a formula. And I wanted to give you some examples of what you might find in your assignment. I went to the Reddit Accidental Renaissance page, and here this looks like a Renaissance painting of perhaps a martyr in the midst of agony and ecstasy. Here's another funnier one. This also looks like some sort of martyr. Some of the things that you may find when you're looking for mimicry or parody or imitation is humorous things, because it surprises us when we are able to immediately recognize those essential characteristics, that kind of algorithm that belong to an entirely different context. I want everyone to take a look at this lecture. This is a makeup lecture because we don't have enough time to meet often enough to fulfill the requirements. So I'd like you to watch this lecture. on the artist as scientist about Nabokov's theory of insect mimicry.